Good day. We are now moving to question 5, which is about building and evaluating machine learning model using Random Forest Regressor. We'll be understanding the theory behind this in our subsequent seminar after you have become part of us. For now, you need to import the suits for the model that we want to use. So we need to import Random Forest Regressor from sklearn. After that, we create a Random Forest Regressor for the data. So we just give it this name, Random Forest Regressor RFR for Melbourne data, MB data. Then we are building the model. So we may not see the outputs, but the computer will log the result. Now we can now use the model to fit our data, the train data, X and Y. So the train part of it is what we are going to use now to run the model. We can now use the test to predict and compare whether the forecast or prediction is good. So the Random Forest Regressor is working there. Now the next thing is to test, make Y prediction. So the YP, which we call Y prediction, will be the model then that will predict using X test. So we are going to get predicted Y, which we can compare to our original Y test and see how far they perform. Now let's check the prediction. I want you to have a lead that the first 5 predictions are. So this one will first be printed. Anything you put in double quotation will be printed as you put it. So now we will now print, after that we will now print the result of the model for the X test for the subset, which is head. You will record that the head will show the first 5 items. So we will see the first 5 predictions. So the first Y is 949,185. The next one 661,501.8, 1,135,125. So these are the first 5 predictions. So the question here is asking what is the first predicted value, so which is 949,185. Then we print the first 5 actual prices for comparison. So the actual prices are, so that you is going to have the lead like before. When you press enter, the cell will give you space to type another thing under. So I have 2 lines here which I want to run together. So I have print actual prices are, so the first one is 815 and the prediction is 949. So the 949 and 815, we see that they are not the same. So this is lower. So the prediction is higher. So it is over predicted here. When we check the second one, 661, 665, this one is under predicted. So when we find the error, which is the difference, so that's some will be positive, some will be negative. Then next is to check the error itself. So the prediction minus the actual for the first 5, we can actually print it using this arithmetic procedure. So this will list. So this is over predicted, this is over predicted, so this is under predicted. That's why it's having negative. So how many of the first 5 items are over predicted? So all the ones with positive sign are over predicted. So the next thing is to be calculating the error. So the total error, so the difference between the prediction and the actual represent the error, but there are different measures of errors for those that study statistics that relate to it. So the one type of error measurement is mean absolute error. The formula is in the system, so the system will calculate. If you now want to print the result now, which is the result is already stored inside this MBRFR MAE, which is mean absolute error. So if you print this now, we will see the result. So the mean absolute error is 206. If we have another model and the mean absolute error is lower than this, such a model will be preferred, because the lower the error, the better the result. So another measure of the error is the mean square error. So now we want to import the module that will enable us to calculate the mean square error. So to use it for the first time, we need to import the relevant modules before we can apply it. You see that the application is towards the predicted y. So now this has been calculated. To see the result, then we just repeat it, or we put print. So this is the result. We cannot really compare the mean square error and the mean absolute error unless we have another model. So we pick the one that have lower mean absolute error or lower mean square error. Another measure is the R square. So R square score, which we also need to import the suit for calculating it. So I'm trying to copy this. So now the suit will be there and I can now calculate. Note the way I put the heading so that I will understand what they mean. This is MB data Random Forest Regressor R square. So I will be able to compare later. So let's see what the R square. R square is a value that the higher it is, the better. So if you have two models, the one with the higher R square will be preferred. This one is 0.7, which means 70% of the variation in the price is explained by all the four variables that we use. So don't bother yourself much about the interpretation if you are new to this field, but you need to practice the calculation so that in future, when we are discussing or having a seminar that expand on this, you will be able to flow along.